Yes, cool. So yeah, let's start, guys. So firstly, what is CP basically? Like, like you all are mostly most of you people are college guys. Yeah, most of you are college guys, so you might be wondering, like you might have heard from a lot of say seniors or maybe from internet, Quora, and all that stuff. Like CP is very useful, competitive programming, and like there is a very uh, like it is very important concept and what all that stuff. So what is CP basically? So competitive programming is basically say solving of various tasks, puzzles, just by coding, like a lot of puzzles and problems. And it is like in initial stages it might seem little tough to you guys, but trust me, it is not that tough. Once you start practicing it, and once you like say study some algorithms, start practicing, it is like very fun activity to do with. And obviously to do with friends it's also much more fun activity to do. So cool, let's start. And also one more thing, it is as you all know, it is very important for interviews too. Most of the like most of no, all the companies, I should say all the companies firstly take coding rounds for jobs and interviews. Firstly they take coding round, and upon like depending on your score in coding round they will shortlist you, and after that they will take interviews, and in interviews also they will ask you algorithms only. So that's why CP is very important for your jobs and your internships too. So cool. Let's begin. Okay. Firstly, I will just show you a simple program in C++ so that we are good to go. Just a program of say some, and along with this, I will make you guys familiar with the very important concept of competitive programming, which is time and space complexity. So, so okay. Uh, let's okay. Let me remove this so that you don't get confused. Let's first take a simple program in which what we will take. We will just take an input of say n numbers and print out the sum of n numbers. Cool. We will take input a. Let us take one more variable. Firstly, we are taking input n, and then we are inputting n variables. We are not storing because we just want the sum. Okay, let me define one more variable, sum. Initially, the value of sum is 0, and at last, I will print the sum. Cool. Okay. Yeah. So let me compile this out. Okay. So see, I made an issue. I printed sun. So that variable was not defined. Now let me run the. So now let us give him the input. Let us take 5 numbers. So this way it printed the sums. So yeah, it was a very basic program, but and I think most of you guys are familiar with this program. I don't need to explain this. I'm just taking input, looping over it, and if someone is facing issue because of say he or she knows only C language and he is not able to see what is this C in and C out. So let me we can do this with scanf also. So if you are confused, just tell me. I will maybe replace it or I will make you understand so that you guys also know about C++. And okay, I hope this is clear. So now let us analyze. Let us go to time complexity and space complexity concepts. So this is simple C++ program where we take input an input number n. Okay, yeah, an input number n, and then we took n numbers as input and just directly sum them. So what is? Can you see also? Yeah, actually I can use C, but okay, just 1 second. Yeah, I can use C also, but I want to make you guys familiar with C++ also. But if you want, let me use C. I can just take this percent %d and this way. This is just okay. Let me compare both the things so that you are more clear. See, in C you to use scanf to take input this way, and in C++ you can just do this C in and then these two symbols and then your variable. So only this much is replaced by this scanf thing. Cool. And for coming to the printing part, in C language, you do by this way. But in C++,
There is
you do.
some interruption in your voice, like
Oh,
it's breaking a bit, some static.
हाँ भैया
there are disturbances. Is it fine now? Okay, just 1 minute. Let me switch.
No, I don't think it's the problem of internet. I think it's your mic.
Oh,
Like when you
So just put your mic a bit away from your mouth.
oh. Is it clear now?
yeah, it's
Cool, cool. Yeah, thanks for pointing out. Okay, cool. Yeah. So where were we? Yeah, we were at the concept of time and space complexity. So now let us study about these complex concepts. Sorry. So what is time complexity? So whenever you write a C++ program or any C program or program in any language, it takes some time to basically run upon it. Like you can see, like you can run most of the programs on your laptop, but there are some programs which you cannot directly run on your laptop. Why? Because when once you run them, it will take a lot of time. So there is a concept of time in your these programs. So what is that concept? So see, like here we are taking input of n numbers, right? So we are looping over. We are taking a loop of n with yeah, we are taking a loop of n with the for loop and taking n numbers as input and just summing them. So anyone tell me, like I can take n numbers, I can take 5 numbers, I can take 100 numbers, I can take 1,000 numbers, but can I take infinite numbers as input? Like it will take a lot of time. Now say I have like I have a lot of numbers stored in an array. Here I was taking input, so there is a constraint, one more constraint also. So for example, consider there was an array. An array contains infinite numbers, like really infinite, as large number as you can think, right? Now I will loop over those numbers and I will sum them and just print them. Simple code. I like right now we are not going into algorithmic part. We are understanding time and space complexity. It's better. It's better. Oh, sir, no, I am not showing the code because right now we are just discussing the concept. We are not going into code, so that I don't want to confuse you right now with the code. Just let us understand the concept first, and then we will move over to the code. Okay, so I was saying that we have an array and we have infinite numbers stored in the array, and I will tell like I am saying you guys just loop over them and take the sum of all elements. So can you guys tell me, like obviously, like if you think logically, you cannot loop over all the elements now. Like infinite is a very big number, so if I loop over all the elements, it would take a lot of time. Can you guys relate with this? But if I take say 1,000 numbers, then I can easily loop over them. Like right now, we are looping over say n numbers. If n is 5, then it was giving result very easily and very fast. So the same way it will give. Yes, sir. It will take a lot of time. Yeah. So you guys can relate logically. Just think logically, not in coding terms. That we cannot loop over infinite numbers. So there is something in this, like all the game. There is something hidden. So that hidden thing is known as time complexity. Why we cannot loop over like infinite numbers? Because when we do for loop, we loop over numbers one by one. Firstly first number, second number, third number. So what is complexity? Complexity is basically measured in terms of big O notation. Big O, this is known as big O. Okay, let me, yeah, this big O, this is known as big O. Capital O, you can say as big O notation. This is the big O notation. This is the major like time complexity. This is the notation which you use to measure the time complexity of any code. And in for loop, as you guys already know, like we move to the numbers one by one. Why? Let us see with the code also. We do I plus plus here. So I plus plus is moving one by one to the elements. So that's due to that the time complexity is known as is O of n. Why O of n? Because we are moving over n numbers one by one. Firstly, first number, second number till nth number. So that's why the complexity of this for loop, when obviously this for loop, is known as O of n. Okay. Yeah. Don't confuse with this O notation. This O, this is just an say a notation to measure the time complexity, and this n represents how like in terms of this loop, like it will run n times, so it is known as n. So now it is O of n complexity. Are you guys clear till now? This big O notation thing.
Yes, sir.
Yeah, cool, very nice. So this is the one. Now the thing is that whenever you run any program, any code, any language, actually not n, yeah, just consider any language. So the limit of n to run an O of n loop is say 1e8 at max. Exact number is I guess near 4 into 1e8. like 4 into 188, but yeah, we can assume it as 1e8. That so if your loop is of size 1e8, then it will run in 1 second. Cool. And if it is more than that, it will take a lot of time. Like for example, if it is 1e9, it will be multiplied by 10 and so on. It will take a lot of time to run your program. For example, if you have, let's say, 1e18 numbers, so it will really take a lot more time to run your full code. So that is the thing that you sorry uh, you can run 1e8 say iteration number in 1 second, approximately 1 second, obviously. So, and this 1e8 number is also approximate. So the thing is, till the time your complexity is say 1e8, it should not be told in terms of this. It can be n square and all that stuff. But yeah, if your complexity number, this number inside this is till 1e8, maybe it can be n square, n cube. Like this was the n complexity, right? This was n. So your complexity can also be say O of n star n, that is n square, or it can be O of n cube. Yeah, yeah,
Hello.
yeah,
What is
yeah.
what is
Suresh.
1e8?
Yeah. Harshvardhan, you are right. 1e8 means like 8 times 0 in this number. Cool? 1, 2, 3, 4, 5, 6, 7, 8. This thing. Actually, I should say it like this way, right? It should be actually it should be 10e8. So are you guys clear with this now, right? So what I was okay, yeah, I was saying that it the complexity of any program can be O of n square. This is known as n square, O of n cube. And what is n here? N is the first input, or yeah, it can vary. Like it is basically the number on which you are looping at. Here we are looping over n, this condition, so it is n. So it can be n square also. For example, say I am taking an input n, and I want to take n square numbers as input. This way. For example, uh, I am taking ns2 and n square numbers, that is 4 numbers, 1, 2, 3, 4. The number sum is 10 because it is taking n. So time complexity of this is n square because it is measured in terms of this n thing. So sorry. Yeah. So what do you say? Yeah. So time complexity can be n square and n cube, and it can be n log n and many other things also. But the thing is that you can till the time this bracket thing is up to 1e8, you can run it in 1 second. But if it will be more than that, then it will not be possible to run in 1 second, and it will take a lot of time depending upon how much above it is. So for example, in this code, okay, just tell one of you tell me in this code what can be the maximum value of n for which this code will run in 1 second. Anyone?
10
Or in case of nested,
10 to
both of
power
them.
4.
Yeah, great. Yeah, can you repeat? Sorry. Yeah, 1e4. Why 1e4, Suresh? Anyone?
because we are doing square, so n
Very
square
nice.
can maximum be
Yeah.
1e8.
Very nice. Very nice. Cool. Thanks, Suresh. Yeah, I hope you guys understand this. So this way, this function can be any polynomial function, n square, under root n, like n log n, cube root n, anything. But yeah, the thing is that the number inside should not be more than this. So this is clear. I guess, yeah, very nice. Many people are answering, so I hope this is clear. If it is not, you can just unmute and ask or put in the chat. So time complexity thing is clear. Now let's see what is space complexity. The same way there is time complexity, na? See, in this code, we are just storing what we are storing. We are storing these two variables, n comma a, and a sum variable. So just three variables. So for example, let me write a code. Let us see here. Let us take an array. Let us take an array here so that the guys who are knowing C only don't get confused. Let's take an array of size n plus 2. Okay, of n directly. And let us keep n here. And I am doing array of I is equal to a. And then here I am summing it. So I'm initially I was just taking an input and just summing them up, but right now I'm storing them in array and then summing up. So yeah, so the code is obviously running. So I am storing it in an array. Please repeat. Can you repeat this? Oh, you meant the space complexity, right? Or time complexity? Yes, space complexity.
Time complexity, sir.
Time complexity. What was not clear in time complexity? Can you ask, please?
The 10E8, sir. 10E8.
So I was saying that. See, I was saying that if there is a simple for loop of size n, I mean I is equal to 0 till n, so you can run at max 108 iterations in that for loop, not more than that. That is limit of your computer, say, to run it. So that was the thing. So just I was saying that any function which is inside here should not be evaluated more than 108. For example, one guy answered that, sir, if it is n square, then value of n can be at max 1e4 because 1e4 into 1e4 is equal to 1e8. So that way. So yeah, cool. So I was talking about space complexity. I was saying just like in this code, what I am doing, I am storing an array of size n, right? An array of size n. So the same way the time complexity was n, the space complexity is also here n. And space complexity is also measured in this term of, you can say, big O notation. So it's this way, this way. Cool. And the maximum local space you can take is 1 is 6, or I guess 1 is 7. The exact number I'm not sure. I guess it is 1 is 7, or in just the 1 is 7 number is just a borderline, you can say. So what I meant by local space is if you take any array inside this main function or inside any function, not a global, it should not be a global array. If it is a local array, then the maximum size of the array you can take is 1 is 6, or say 1 is 7. It is, I guess it is 1 is 7, but I don't remember exact number. So you cannot take an array of size more than that. If you will take an array of size more than that, and then it will give you, say, memory limit exceeded error. You might have faced that error in your
Yeah, I have one doubt. I did not get the sixth line in the code.
sixth line.
Yeah.
This line. Okay, you might not be knowing C++, so just assume this was the line.
No, actually, I know C language, but I don't know C++.
You know the C language, right?
Yeah, I know.
Yeah, so this is the C language, right?
Yeah.
So this way you can take an input of number n, right?
Yeah, this is clear. But what is it that scene greater than?
Yeah, this is the way of C++ to take an input. This is the fixed thing, and this you just need to mention variable here. You just need to you don't need to write %d in C++, right?
Yeah, and what is the mean the greater double greater than?
Actually, you don't think of on meaning. This is just a syntax thing. Like
Okay.
in scanf also, you are putting this %, then scanf, then bracket. So there is no particular meaning. This is just a syntax. So that way, this is also a syntax of C++. Don't confuse in this. If you don't want this, if you don't like this, just think it is this. Cool.
Okay.
Yeah, cool. So I was talking about space complexity. So I was saying you cannot take an array or total space more than 1 is 6. So that is the thing. You might have faced some memory limit exceeded error in your online platforms, or maybe in your local laptop too, if something is there. So so that is the thing. So this is known as space complexity. So just let us quickly do one more thing, and then we will move to some new things. So the same way I did a code of, say, I took an input of 2 and took n square numbers. If I am taking an array of size n square, so the space complexity would be n square, right? You guys can relate it, right?
Yes, sir.
Yeah, so if you have any doubt till time and space complexity, tell me. Otherwise, I am going to move on binary search concept, which is a very... Oh, okay, I will tell you one more concept before that, and then we will move to binary search. And obviously, in full of today's workshop, and in second part of the workshop also, we will be using time complexity concept. So that, because that is the good way to do CP, like best way, I would say. Space complexity does not depend upon int or double. Very nice question. Very nice. It depends upon int or double. Very nice question. Sovit. It depends upon int or double. Actually, the int is of size 4 byte, and your long are more than that. So obviously, it depends upon that. Very nice. So if you take long, it might happen that you cannot take. Obviously, you cannot take size of array of long int is equal to size of array of int. There would be some difference. Just repeat the last part about the n square space. Yeah, I was Venugopal, I was telling like previously I told you that I am taking an input of n and looping over 0 to n square to do the sum. So some guy answered that, sir, the complexity will be n square and we can take n is equal to 1e4. So I am talking that I am taking input n and I am storing numbers in an array, n square numbers in an array. I am taking n square input, so my space complexity here would be n square because my array size is n square, right? Also, one more okay, just leave that. So yeah, okay. Now let us quickly do one thing, and then uh, we will. Now I'm removing this array because it is not actually needed here, and I don't want to use it. So yeah. So this was the first code we wrote. So as you guys, as we know, the time complexity of this code is n. Okay, let me do one thing. Now what I will do is my problem is to do sum of numbers from 1 till n. I'm not taking input as n numbers. I want to take sum of numbers from 1 till n. Right? This way. So input just input n and it is giving you the numbers. That 1 plus 2 till 6, right? So the what is the time complexity and space complexity? Quickly tell me. Can there be two codes with same complexity and they both take different time? Actually, it can happen, yeah. It can happen, but not like the time difference would not be that large. Why it can happen? Because of some computation. For example, if you're doing a for loop and you're just simply adding your variable, then it will not take much time. But if you are doing a lot of say highly complex computation, say maybe some percentage, multiply, divide, and all that stuff, obviously it will take a little more time. But the measurable way to do the way to measure time complexity is in terms of n. Oh, even storing n variable given space complexity of n, right? Yeah, obviously it will given space complexity of n, but yeah, it is right because array is also say n variables. But why we are not talking about variables here? Because here there are only 3 variables, and 3 variables are very small to count. Nah? You can say of n plus 3, but yeah, that doesn't make any sense. Okay, I was asking, anyone quickly tell me what is the time and space complexity of this code? Quickly. Time complexity, obviously you know already, but just tell me. Quickly, any guesses?
Time complexity is open.
Yeah, and space complexity?
Oh, one. I
Very
think
nice.
array was not this.
Yeah, array was not taken. Yeah, very nice. Varun, space is not n because we are not storing anything. So this is known as O of 1 or say O of constant space. Why constant? Because we are taking 3 variables, and if you want, yeah, 3. 3 also works. You can say O of constant space. Sorry for the wrong spelling. Oh my dear. Yeah, cool. So yeah, very nice. I hope you are clear with this concept. So I'm going to quickly do one more thing. As you guys already know, like to do sum of first n numbers, there is a formula n into n plus 1 by 2. So what I am doing now is sum is equal to n into n plus 1 by 2. Just take it here. We don't need here this also. So if I do this thing, yeah, answer is same. So what is the time and space complexity of this code? Tell me. This new code.
Oh, one.
Yeah, y of 1. Yeah, y of 1 because right now we are not looping over n numbers. Now we are just using formula to do it. Yeah, great. So very nice, guys. I hope this is clear with you. So now let us increase the speed little bit because we need to cover binary search also and DP also. So right now it is 1:30 already because I want to do the beginning start. Space is 2 words. Yeah, you can say 2 also. So yeah. So now we have 1.5 hours left. So we will try to complete binary search in say 30 to 40 minutes at max, and then rest of the say 50 minutes approximately, or maybe 60 minutes. We might extend for 10 minutes just. We will devote over DP. DP, you might have heard about DP, which is a very important concept. So let us quickly.
Will we get the recording for this?
No, actually you won't be getting that. Sorry.
Okay.
What type of problem have 2 into 2 to the power n? Yeah, very nice question, Nikhil. Uh, okay, I will show you some code. maybe after certain time, because let us move over binary search first. But yeah, your question was nice. What type of problems have? Just remind me at the end. I will obviously tell you. Yeah, print all subsets. Very nice. Yes, it is exact answer. But I will show you the code also, Nikhil. So just remind me at the end of the meet. But right now, yeah, because we don't have much time, so I want. Let us. So see. Okay. Okay. Let me firstly do say. Let me firstly show name. Okay, so now the problem statement is, listen the problem statement carefully. You are given a sorted array. Already it is sorted. You don't need to do anything. You are given a sorted array, and it contains distinct numbers. Say 1, 2, 3, 4, 5, 1, 2, 3, 5, 10, anything. It contains distinct n numbers. Uh, Maybe take input, or maybe it is already given, your wish. So what your task is to find the position of given number. I will tell you a number and tell me the position. For example, say you have an array, say 1, 4, 7, 8, and then say 100. So my question is, tell me the position of 7. So you can say 3 in 1 based indexing, and in 2 based, 0 based indexing, maybe 2. So this is my question. Okay, linear search, very nice. So let us quickly do the linear search, not spending much time. I'm not taking input, I'm just taking array directly, because yeah, array 1, 2, let us take big 1, 5, 8, 9, 10, and my target number is equal to, okay, let us take input of target. Okay, let us quickly do this. Yeah, my target is 8. Now, as one guy said, do linear search. What I will do is, if I will do a for loop, and if array of I is equal to target, what I'm going to do is, my answer is I in 0 based indexing, and I'm going to break it because I don't want to move forward anyways. Yeah, you can print there also, but it's your wish. Okay, let me take answer variable also. So this is my linear search, as someone already pointed out. Oh, there was some expected name. Okay. Oh, I meant to take vector actually.
What you wrote in for loop?
Yeah, just 1 minute. Okay, n is also not defined. N is 5 for us. We have taken 5 numbers.
So I think you haven't defined LLI as long int.
Yeah, sorry. Actually, my habit is of taking NLI, and my template is something different. So I've changed my template for today's meet. That's why. Yeah. Okay, so answer is 2. That the index is 2. In 0 based indexing, target was 8 and my index is 2. So this is my known as linear search. I think binary search will be faster because time. Yeah, very nice. Yeah, I guess you already know binary search, but yeah, we need to start it from the beginning. So yeah. So this is known as linear search. Its time complexity is O of n, and space complexity is also O of n, because we are storing an array. This is simply an array. Vector is also an array. So don't worry about this. Just consider it as an array. Don't just forget. Or if you want, I can take an array also. But yeah, I'm just looping over it and checking it. So yeah, cool. So I think, yeah, cool. Sorry. Let us move over binary search now. Now let us see what is the binary search. Let us try to understand logically, and then let me copy this out. So let us try to understand first what is binary search, and then we'll code it up. Yeah, see, now yeah, now one thing we have is linear search. Now there is one more efficient way, like one efficient way to do something known as binary search, which is a very efficient way of doing search or this type of related task in an array. So let us try to understand it. So say this is our array. This is our array, right? It is containing some numbers, say 1, 3, then 5, then 10, and this way there are some numbers, and these are in sorted order, right? There are some numbers. So my task was to check what is the position of say 10 here. I want to check the position of 10. So binary search, what we do? Firstly, we check the like middle number. What is the middle number here? There are 1, 2, 3, 4, 5, 6, and 7, right? 10 numbers. So this is the middlemost number. This one. So firstly, I will check this number. Say this is say 15. This is 15, and hence so forth. So this is 15. Firstly, we will check this middle number. Cool. This is 15. So 50, and we are querying for this number 10. So 15 is more than 10. Then what it means logically? Logically, it means that as this is a sorted array, so obviously all the numbers ahead of this 15 are more than 15, right? This might be 16. This might be 20. This might be 30, 100, and so on. So all the numbers which are more than this in terms of index are obviously more than 15 and obviously more than 10 also. So my position of 10 cannot lie in this subspace. Do you agree with this point? Let me repeat first. Okay, let me repeat first. I have an array and I told you that this array is sorted and I have distinct numbers. So first is 1, 3, 5, 10, 15. Yeah, maybe this is 20 and so on. So I want to find the position of 10. I want to find what is the index of number 10. So firstly, I will check the middlemost number of this array. This is an algorithm. So the first step of algorithm is start from the middle position. And what is the middle position? This is the middle position. This thing, right? And my number at middle position is 15, and 15 is more than 10. So if as 15 is more than 10, and we also know that all numbers which are more than 15 in terms of index, that is this and this, will have a value more than 15 now, obviously, because this was a sorted array. So can I say that my 10 will not lie in this subspace, this circle? Can I say this? Anyone?
Yes.
Yeah. So I can say that my number will not lie in this subspace, and this subspace is useless for me. I will not search in this subspace. So just cancel this out. I'm not interested in this subspace. So I have a new array, which is this array, only containing 4 numbers. Because 15 is also more than 10. So initially there were 10 numbers. So in just one step, as you know, in just one step, and obviously to get middle number, I can just take 1 plus n by 2. So that is also not an issue. And excess of middle number can also be directly done by array of index. So that is also not an issue. So just in one step, I removed this whole subspace. I just deleted this whole circle subspace, and now my new array is this, containing 4 numbers. Any issues till now? This is my first step of binary search. So any issues, do tell.
No, sir.
In right part, it will not be present. Very right. Anyone any issues? Cool. I hope.
Nothing, sir.
Cool. Thanks. Yeah. So just forget about this part, and this is our new part. So now again, I will take the middle of this thing. Now there are 4 elements, and what is the middle? Actually, there is no middle because there are even numbers. So let us take this as middle, right? This 3 as middle. Any number, you can take 5 also. It is just your wish. But let us take 3 as middle. So now I check that now at my middle position, number is 3, and 3 is less than 10. You all know. So as 3 is less than 10. Sorry. So as 3 is less than 10, so can I say that all the numbers lying behind 3 index wise will not be greater than 10? Obviously they will also be less than 10, this part. As 3 is less than 10, so all numbers before 3, numbers greater than 3 might be, obviously will be greater than 3, so can be equal to 10 also. but numbers behind 3 cannot be greater than 10. That is guaranteed because they are less than 3, so obviously they are less than 10 also. So can I just remove this subspace? This, okay, let me take black color. Can I remove this subspace now? This part. Anyone? Please reply. Okay. Tejas, can you reply?
Yeah.
Yeah, very nice. So now I can remove this also. So what is my new array? This one. This containing just these two elements. So this is my new array containing two elements, 5 and 10. So now my problem C. In just 2 steps, I removed a lot of elements. Firstly, I removed 1, 2, 3, 4, 5, 6 elements. Now I remove 2 elements. Now I'm left with just 2 elements. Now if I take middle, it can be anything. If it is 5, then you know that this is also not my, all numbers less than 5 are also not greater than 10. So let us remove this also. So I remove this now, and at the last point, I am just left with this. I'm just left with this one number, which is 10. And yeah, then I got my answer. So total, how many steps? Total, it took 3 steps, just three steps. But in linear search, I looped over full array. So looping over full array has complexity O of n, as you already know. And here n was of n, value of n is 10, so it will be 10 steps. But with this algorithm, which is known as binary search, I used only 3 steps. Here I used 10 steps. So can you guys see how many steps I reduce? So do you think it is very nice algorithm, right? Are you guys getting the beauty of this algorithm? Like, I personally like this algorithm very much, like, because like, see how beautiful it is, like, in like how much logical it is, like the numbers are greater, so just remove the space. So yeah, okay, I hope you guys, yeah, cool, very nice. Okay, like, am I too slow? Like, am I going to too much beginner level, or is it fine? Like, because I consider many of you might not be knowing anything, so that's why I started from pretty beginning level. So if it is seeming to be too slow, do tell me. Fine, sir. Okay. If like, many people might be feeling that this is very much beginner level, but yeah, cool. Okay, and yeah, those ever who have not slow, sir, cool. And those ever who have said it is fine and not slow, are you guys clear with this binary search? Like, anyone who didn't knew binary search first and now is clear? Cool. Well, yeah, stop. Yeah, cool. Sir, which language are you going to use in this? Okay, if you want, I will use C, or I might use C++ also. Okay, let me use C only. Many guys might be confusing. Actually, I'm not using C++ function, so cool. I will use C. Cool. C++. Okay, I will tell both. There is only one error, so I don't think anything. Yeah, so I will code up this problem now, this one, which we just studied. And also let us print steps also, so that we can prove that it is taking 3 steps. And we will properly do like printing, so that you can see it as a simulation, say. Yeah. Cool. So here I am taking, like, I just take an array. So this is just an array also. Okay, let me take an array only. Actually, I've, yeah. Now let us forget about this vector, because many guys are not clear with this. I take 3 inputs. Okay, let us make this of 10 size. Let us quickly do this. How many numbers are 10? Yeah, 10 numbers are there. So let us write the code of binary search. Now listen to my one thing. Like, I am telling it from my experience. Okay, is it not okay? Cool, no issue. Yeah, I am telling it from my experience that many people confuse with the binary search code. Like, there are some corner cases. Like, there are many codes available on net which are not purely correct. There are some issues. Like, if I am not wrong, I am not sure, but like maybe 1 to 2 years ago, when I studied binary search first time, then I took the code from Geek for Geek and it was wrong. Vector is like an array whose length can be changed. Yeah, right. But right now, let us take an array only. So I, like, 1 to 2 years back, I took an code from Geek for Geek of binary search, and the corner case which I'm going to tell you today, that was wrong there also. So like, focus over code very, like, it is very confusing. Like, truly saying, like, once I studied the algorithm of binary search many times, I also confused with this code because there is one say corner case. So I will tell you the best way to do binary search and always do it this way only. Like it is like tried and tested. So cool. So there are firstly two variables in binary search. First is the beginning and second is end. Beginning is beginning is this first pointer, index of this first element, and end is this one. So my beginning is obviously 0 because of my zero based indexing, and end is n-1 because of zero based indexing. So there is a loop. There is a loop in binary search. Change n to 10 in the code. Oh, thank you. Okay, cool. Thanks. Yeah. Okay, let us do this also 10 or anything 9 maybe. Yeah. There is some condition. Okay, someone is okay. I'm muting you. Inshu Jain, if you don't want to ask any question. If you want, you can unmute obviously, but yeah. Yeah. So there is some condition here. Some condition. Okay, I cannot write this. Some condition, but I am not going to confuse you right now with the condition. So assume there is some condition. Don't focus on this right now. I don't want to confuse it. So firstly, I will take mid element. As I already told you that I take mid element. How I take mid? Beginning plus end by 2. This is the mid index. So okay, to don't confuse it, let us take mid index. So this is my mid index. Now let us take one more variable, mid element. You can do in less variables also, but yeah, to do in detail, let us take this. Yeah. So mid index is obviously beginning plus end by 2, and mid element is array of mid index. So now my problem is if mid element is greater than my target, I want to do something. Else, I want to do something. Okay, I'll do it this way. Else, if mid element is equal to target, and else in this else obviously if mid element is less than target. Cool. So if my mid element is greater than target, actually meet is being recorded, but we will not we cannot provide you the recording. So yeah, sorry for that. Yeah, I told you that if my mid number is greater than my target, then obviously this is the sorted array, so I can remove all elements which are more than this, like in the terms of index. So I only need the previous array. So can I do index is equal to mid index minus 1 as my new subspace? Like this was the end pointer. I am moving my end pointer to here because I am removing this subspace. So can I do this? And mid index minus 1, why minus 1? Because mid index was 15, so it was also greater than mid. Oh, sorry, greater than my target, so I don't need it. Is it clear, anyone?
Yeah.
Okay.
Yes, sir.
Yeah. Yeah. So what I did, I removed this part, and yeah, now my subspace is this thing. Also, one more thing. If my mid element is equal to target, then very nice. I got my answer. Answer is mid index, and I can break and see out answer. Initially, we are taking answer as -1 because it can also happen that the number is not existing. Then I can just print at the end -1, or maybe you can say if answer is equal to -1, you can say that number does not exist this way. And in else condition, if mid element was less than 8, so I can remove all elements before that. So what I can do, I can move my beginning pointer to mid plus 1. Oh, sorry, mid index plus 1. Cool. So I hope this is clear. If this is clear, then I will tell you the last part of binary search, which is this condition. Just reply if it is not clear, or if it is clear, anything.
Yes, sir, it's clear.
Cool. So now let us see the condition. This full thing is clear. So what we are doing logically, we are moving our beginning and we are moving our end pointer to something to reduce our search space. So now my condition is that till the time beginning is less than equal to end, run this loop. And after that, exit the loop. Let us understand it properly. Let us do this with the simulation. I will print beginning first, end first. Cool. And also I will take a count of total steps. Count. So that you guys are sure that how much steps it is taking before printing out my result. I will print count. So let us see now. So see, initially beginning and end were 0 and 9 because of 0 based indexing. Then beginning and end were 0 to 3. Why 0 to 3? Let us understand. So initially what would be my middle element? This will be my middle element. So no, so not this, I guess. This will be my middle element because of these are even number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So this will be my middle element. So my target was 9. So it see that this 10 is greater than 9. So it removed all this. And just take these 4 numbers. So taking this in the 0 based indexing 0, 1, 2, 3. So my new beginning and end are 0 to 3, right? Yeah. So now once it is 0 and 3, what is the mid of 0 and 3? 0 plus 3 by 2, which is 1. This is my 1. One element at this position is 5. 5 is less than 9, so it is removing these 2 also. So new search space is this 8 and 9. And the index of 8 is 2, so search space is 2 to 3. This thing. So now it is 2 to 3. Mid of 2 to 3 is 2 plus 3 by 2. That is 5 by 2. It is 2. So the second element is 8, which is again less than 9. So it removed this element and remaining I am left with only one element. So this is 3, 3. And yeah, I got my answer. Total steps it is taking is 4. Is it clear now? But can you guys see now? If I will be doing linear search, my total steps would be 10. So now my total steps are 4. It reduced so much. So are you guys clear with these things? That the method of taking. Okay.
Yes, sir.
Cool. Very nice. Very nice. Very nice, guys. So yeah. Also one more thing. So this is clear. One thing I need to explain you. I need to explain you 3 things right now. This condition. Something about this, and at the last I need to tell you about the time complexity. So let us see firstly these conditions. So see, in this problem the conditions are in such way that if my mid element was greater than target, I need to do this. If it were this, I need to do this. But depending on questions, it can vary also, right? So yeah, and also there is you can directly write this answer is equal to mid index na here also. But yeah, it is not. No, sorry. In this problem you cannot write, but in some problems what happens is they have told you to find maximum number which satisfies some condition. Okay, we will do a problem. We will do a problem at the end. So I will tell you that at
I have one doubt.
Okay,
Yeah,
tell me.
Yeah, what is the function of this? You written the 12th, 13th line. I did not get it.
12th line is just to print beginning and end, and 13th line is just count plus plus. I hope you guys know count plus plus. It is just is equal to count plus 1, right?
And what is exactly? Yeah, I know that, but what is exactly the 12th line you written? I don't
Okay,
understand
actually
it.
you guys are confusing with this thing. Sorry. Actually,
I mean,
this is just to print.
and
This is just to print the thing. You can do this way also. Okay. Now is it clear?
yeah, this is clear. Yeah.
This is just a print. So wherever I write C in C out, not just consider it as a print statement. But yeah, print and scanf and print respectively. So yeah. Okay. Yeah, don't confuse with this. Try to understand what was the edge case. Okay, great. Why? I will tell you. Why if the number was what if? Yeah, if the number is not found in the array, let us take the example only. Why to ask it? Or let us take number say 7 is not present. Let us take the number. So it searched all the space it can. At the end, it printed -1 because it cannot find the element, right? Cool. Sarthak. And what was the edge case? Also take unsorted array. No. It will not work in the unsorted array. Why? I should tell it explicitly. So binary search will not work with the unsorted array. Maybe you need to sort it first. and then do it, or your wish. Why? Because see, what I did here is, if mid element is greater than 10, greater than target, then I was removing these all elements. Why? Because these were guaranteedly more than 15, because this was a sorted array. But in unsorted array, we cannot make such guarantee. So binary search does not work in unsorted array. It won't be able to search. We never said to do print -1. How did it print -1? Okay, I will tell you just a second. So okay, so guys are confusing with -1. Cool. So see, what I did initially, I made answer is equal to -1, and it never entered this condition because mid element was never is equal to target, so it never entered this condition. So that's why it breaked. Answer is equal to -1. Actually, this is nice doubt. Let us visualize it. Okay, I will visualize. Let us take a small array and quickly visualize this. Oh my bad. Oh, so I should I explain -1 with like some simulation, or is it fine? Just tell me quickly. Till then, let us see. You need to do beginning less than end, because obviously if beginning is greater than end, so it doesn't make sense. Now beginning should be less than end. We made the pointers this way. And what was the basically क्या कहते हैं corner edge case? Edge case was that you need to put end is equal to mid -1 and beginning is equal to mid +1 here. Because let me take an example. It is a very cool example. Let me think first. 3 plus 2 by 2. Yeah, let me take an example. Very nice example. Okay, let me quickly take this. Someone is unmuted. Please mute. Like there is a lot of disturbance from your side.
So the terminal ones.
What?
Can you show the terminal ones?
Terminal? Oh, terminal.
Yeah.
Cool.
Okay.
Yeah. Now I'm going to tell you the corner case. It is a very nice case. Like thanks to the guy whoever asked about this. Yeah. See. Now. Now basically, let us take an array. Let us take an array of size 4 only. I am taking an array of size 4. The numbers are say 1, 3. Please mute yourself. Like there is disturbance. Whoever it is. My array. Someone is unmuted. Please mute. Like there is disturbance from your side. Yeah, parts. Yeah, see, I have an array. I have an array containing 4 elements, 1, 3, 5, and 8. Cool. Now my task is same, but my target now is say, what to take target? 1 second. Let us take my target as 8. Cool. Let us take my target as 8. So initially my mid element will be 3, and as 3 is less than 10 or less than 8, I will remove my this sub array. Now my new sub array is this. Cool. And see, what will be my value of my beginning pointer? My beginning pointer will be equal to 2, and my end pointer will be equal to 3. Because initially my beginning was 0 and end was 3, and mid of this is 0 plus 3 by 2, that is 1. So this is the first position. So I checked it, but it was not available. So I came over here, this 5,8. So my now my beginning is 2 and my end is 3. Till now, obviously it will be clear. Yeah. So now see, now if I take beginning plus end, that is 2 plus 3 by 2, which is 2 plus 3 is 5, and 5 by 2 is 2. That is this position. So my this position is less than 8. So logically I should remove these elements and move my beginning pointer to this thing, mid plus 1. But consider the case, if I forget to do plus 1 here, and if I did just this thing, beginning is equal to mid index here. If I did just this thing, beginning is equal to mid index. So initially my beginning is equal to 2, and my mid is also equal to 2. So my beginning will not change. My beginning will again come 2, and it will be stuck in a while loop. Did you guys got this point? So the edge case was that you should do beginning is equal to mid plus 1 properly. Many times people do beginning is equal to mid index whenever they are beginners. So it got stuck into while loop because my beginning was 2 and end was 3, and mid of 2 plus 3 by 2 is equal to 2. So my mid, this is my mid. This is my mid. So if I, instead of doing beginning is equal to mid plus 1, if I did directly beginning is equal to mid, so my beginning pointer will not change the position and it will be stuck in the while loop. Are you guys clear? Yes. If you could repeat it once more. Okay, I will. I hope this. Okay. Can you repeat, sir? Okay, I will repeat. I will repeat. Many are having doubt. So initially, I had an array containing 4 elements, 1, 3, 5, 8. My beginning was 0, obviously, and end was 3. So my mid of 0 plus, and my target was this 5. Oh, sorry, not 5. This 8. This 8 was my target. So I did beginning plus end, that is 0 plus 3, that is 3 by 2, that is 1. So I checked my first index. My first index was 3. So 3 is less than 8. I will remove all these elements, remove them. Now my new search space is this. And my beginning is equal to 2 and end is equal to 3, right? And my beginning plus end by 2, beginning plus end 2 plus 3 is equal to 5 and 5 by 2 is 2. So my mid, this is my mid value. And I checked my mid value is again less than 8. So I should remove all the elements behind it. But if by mistake I did beginning is equal to mid instead of beginning is equal to mid plus 1, then I will be stuck in the while loop. Would checking the beginning and end indexes value improve the complexity, or would it not matter that much? You meant in at the actually it will not matter. It will not matter because you don't know na that those are the element or not. So it is just a waste of time because anyways it is going to give same complexity. But yeah, I can understand that at this point you are saying it because this time it is the last element. But logically it will not give, and we will and we will see it while understanding about the time complexity of binary search. Oh, we are stuck at 2. Yeah, right. We are stuck at 2. So this was the corner case, and many people don't know about this. Like really, this is very important case. Like very important, literally. So always, like maybe remember it that always you need to do end is equal to mid minus 1, beginning is equal to mid plus 1, and just one advice. Or okay, we will do a question maybe that. Okay, I will tell you that with the question. And here put beginning less than equal to end. Just maybe learn this, or maybe like because I proved this and I faced wrong answers, and that's why now I have made a proper template for this thing. So always put beginning less than equal to end is equal to mid minus 1, and beginning is equal to mid plus 1. Always do this thing. Cool. Because if you do say beginning less than end, and if beginning and end are equal, and that is the only element, maybe say, for example your array size is 1, then also it not face the condition. So there are those little corner cases in your binary search, so which you can save you from getting stuck in those cases by just writing this code always. So yes, this was clear. -1 was clear. Okay, let us quickly do the time complexity analysis, and then we will quickly do one question quickly and then to the DP. So let us make a target to complete this binary search by 2:15, and then we will have 45 minutes or maybe 55 by extending 10 minutes, and which are sufficient for our what you say DP. Okay, just give me 1 minute. So cool. So obviously space complexity is O of 1. I am not showing anything, but what is the time complexity here? Many might be knowing from maybe internet that it is what you say it is log n, but let us understand why. So see, I had an array initially. To which I am divided. At each step, I am basically removing 1/2 of my array. That you already know. Like say I am taking mid element, and maybe maybe I am removing the previous half or maybe the second half. But it is guaranteed that always I will remove 1/2 of the array. Maybe the array the half after it or the half before it. So at each time I'm reducing my search space to half. Like initially, for example, say your search space was of size 100, then it came to 50, then 25, then 12, then 6, then 3, then say 1 or 2 or 1 or anything depending on your that thing. So at each time it is guaranteed that you are reducing your search space by half. So due to this, the time complexity is log n. You obviously know the log function. So let us maybe analyze it with one more case. Yeah, let us analyze with say n number of power 2 so that it is more clearer. So initially my number was 8. Initially my number was 8. Basically the search space, this array size, or say 16. Once I remove one half the array, obviously 8 elements should be removed, remaining elements are 8. Now my new search space is 8. Again I removed half, it is 4. Again half 2. And at the last point 1. So basically for 16 elements I did it only 5 steps. So this is known as log and time complexity. If you want to mathematic, okay, uh, are you guys, yeah, great. This is fine. Are you guys clear with the logic? I don't want to show mathematical proof. Why? Because mathematical proof is also available on net, but you should understand it logically first. Because whenever you are going to solve a problem, so obviously you cannot like prove it at that time. You need some understanding. So understanding is that obviously that I am reducing my search space to half. Like for example, it was a very big number of power 2. Why power of 2? Because that makes things more clearer. 64. From 64 it came to 32, 16, 8, 4, 2, 1. So it is like dividing the search space by 2. So are you guys clear that it is log n time complexity? Log n means that it is taking log n number of steps. Initially it was taking n steps in for loop. Now it is taking log n steps. Is the logic, are you guys like, is the logic clear? Are you guys getting a feel why it is log n? Like it is reducing the search space by half always. If it is not clear, obviously ask. Okay, let me ask some random person. Shruti Sriram, is it clear? But how long does sorting take?
Yes.
Which okay, cool. Which sorting you mean, Venugopal? Initial sorting, do you mean initially the array would be sorted? Like if it is obviously, but if it is not sorted, then it takes n log n time complexity. But yeah, then a question comes to mind. If it is taking, we have to sort it initially, right? Yeah, you have to sort it if it is not, but it depends. Like one question can come to your mind that sir, it is taking n log n for sorting step. Then yeah, log n is not an integer. Yeah, you round it to its upper integer, na. Obviously the steps would be an integer number. Log n is just an need to use bubble sort. Why bubble sort? You can use merge sort also, na. Merge sort has lesser complexity than bubble sort, right? What is your name? Kuri, I guess. Yeah, so yeah, one question comes to mind that sorting also take n log n at max. There is no sorting algorithm which take less than n log n time complexity. But binary search is taking log n. So if sorting is already taking n log n, then why to do binary search? We can just do linear search also, na? Because overall my time complexity will be n log n anyways. So the reason for that is maybe they have already given, like in many questions they already give you the sorted array. So in that case it is very useful. But other case where it can be useful is like sometimes in some question you need to do binary search again and again. Like there are types of query questions, say you need to do binary search many times. So that way it is very helpful. Okay, one thing. Okay, let me make you guys just last thing clearer with one say question. I'm just framing the question on my own, so just binary search question. And you will get this code obviously, so don't worry about this if you want. Directly you sort. Yeah, this works in C++. Which this guy is saying, the Vendra is saying, which algorithm is best to sort elements. Actually, once you start using C++, you will use sort function. There is inbuilt sort function. You just need to write sort sort. So yeah, we can use instead of to. Yeah, obviously you can use, but my advice would be if you are using C++, then obviously use sort function. Na? It has the lowest complexity. They have, because C++ implemented guys have implemented it, so they have taken care of various factors. So let us not fight with the sorting thing right now. Okay, let me frame a question. Yeah, just let us quickly frame a question. Let me frame it this way. Let us take array this way only. I have a function, int function. I have a guy, say, whose name, some smart guy. Okay, and I pass to this guy a number a. Cool. Just forget about binary search. Just forget about this. I'm just framing a question. Yeah, I'm just framing a question. I have a function named smart guy. What this smart guy does, like basically my smart guy loves number which are say uh greater than say 8. Anything. This smart guy loves all the numbers greater than 8. Maybe 8 is his lucky number or something. He does not like the numbers less than 8. Cool. Okay, sorry. I did a mistake. He likes the number less than 8. Less than equal to 8, not any number greater than 8. Like he is offended if you give him a number greater than 8 and he likes only the number less than 8. So what this guy does, if you pass him a number less than equal to 8, then he returns 1. If you pass him the number greater than 8, obviously in L condition he returns you 0. This is my smart guy function. This is just a function, like hypothetical thing. So it is his own wish, he will do this way. So what he wants? Okay, let me remove 8 from here and let me put say 6 and here say 7. Yeah, this is my new array. So my task is that find the greatest number present in this array which my smart guy will like. Find the greatest number present in this array which my smart guy will like. Obviously he will like 1 because 1 is less than 8. He will like 5, he will like 6, he will like 7, but he will not like 10 because he only likes number less than equal to 8. So he will not like all these numbers. So maximum number he likes is 7. Obviously this is clear. Problem statement is clear, I hope. Quickly give a yes. Quickly do this. Anyone? Or maybe no also. Just problem statement. Yeah, cool. Let us quickly move. So this is definition of my smart guy. So I want to find the maximum number. One thing I do is do a for loop and call this function with all the numbers, and till the time he returns at the maximum number for which he returns 1, I will just output it. But efficient way is to do binary search. Beginning is equal to 0 and is 9. I will write it again so that quickly write it again. I do. Int mid is equal to beginning plus end by 2. If array of mid. Okay. I need to call this function first, right? Let us take int response is equal to smart guy mid. Oh no, not mid. Sorry. Array of mid. Array of mid. If my response is equal to say 0, so it means that he does not like these numbers, and obviously he will not like any number greater than this because we are given a sorted array. We can use it as a boolean. Yes, very nice. We can use it as a boolean, but I didn't use so that you guys don't confuse it. But we should use boolean here. I intended to use boolean only, but as you guys were confusing with C in C out also, so that's why I didn't use that. But yeah, you were right. Very nice. So if my response is 0, it means I cannot take this number and obviously not numbers more than that. So I can do end is equal to mid minus 1. Oh shit, I should ask. And else means if response is equal to 1. What should I do if response is 1? Anyone tell me and explain me, please. Okay, let me pick out one number. Set target equal to 1. Are you late for message? Okay, I will read this message afterward. Yeah, Sai Akash, tell me. Janpati Sai Akash, tell me what should come here. What condition should come here in this else thing? Or maybe this Chaudhary Nishant. Please quickly tell me. We are already lack of time. Anyone tell me. Maybe any guesses also work. What I'm just asking, what condition should come here? Make any guesses, na? Or maybe explain me why here it came end is equal to mid minus 1. Navendra Agarwal, can you speak? Can you unmute please?
Response is 0 if it is greater than 8. So
Yeah.
doing -1, we reduce the index. So it goes to, it
No,
searches within.
why we are doing end is equal to mid minus 1? Why we are okay? First, tell me the thing. When I am doing end is equal to mid minus 1, logically, obviously, as I already told you, at each step of binary search, we are removing half of the array. So which half I am removing? Left half or right half?
Right half.
Okay, because obviously we are moving end pointer to previous thing. So why I am doing end minus 1? Would my like end is equal to mid minus 1? My answer cannot lie in that right half.
Because all the numbers on the right half will be greater than the number which we
Yeah, great, Suresh. And what condition should I put here? In else, if response is equal to 1?
N will be the required number.
Yeah, now comes the twist. Let me tell you one thing. Now I got why you were not answering. It is a sorted array. We need to do beginning is equal to mid plus 1 to remove the left half. We need to do beginning is equal to left plus 1 to remove the first half, left half. But there is one thing here. See, we need to find the maximum element for which the response is 1. So we will put answer is equal to maximum of answer, comma, what you say, array of mid also. Actually, there is no need of maximum. We can directly do array of mid also. So one thing is we are moving our beginning pointer to right part. So and we are removing the left subarray. Why? Because my answer would my answer may or may not lie in the left sub, like not at least not before than this. Why? Because I need maximum element for which response is 1. Yeah, you are right. 1, 5 are also the answers which my smart guy likes, but I want the maximum element. So that's why I am removing my left subarray. But along with that, obviously it is possible that this is only my answer. So that way I am updating my answer also. Is it clear? I understand why you are getting doubt. It is not your issue because previously we had only single answer, but here we had more than one answer. 1, 5, 6, 7 are the number which my guy like, but I want maximum from them. So that's why I update my answer here also, and I did beginning is equal to mid plus 1. And if you want to be on the safe side, maybe do this thing, but this is not needed actually. Are you guys clear now? If it is not clear, tell me because this is little confusing. Just quickly, please quickly do. I need to start DP also. Clear. Anyone, if it is not clear, please tell.
Yeah, what is it? Give the max of the answer and that line.
Okay. Sir, please explain. If response is 1, end will be and, right? End will be and, matlab? End will be and. I didn't get your language actually. Can you repeat, please? Answer will be this. Oh, yeah. I already told maximum function isn't necessary here, right? Because I'm always taking the last one, removing the range. But yeah, I just put it so that you can get a feel that we are getting the maximum number. But yeah, I already told it is not indeed. Someone said yeah. Okay, answer can be that thing, but the thing is we need the maximum element. So for example, let us quickly draw one last thing. With this, you would be fully clear with the binary search. I can guarantee that if you get this question, because this was one more twist of updating answer along with that. Let us take 1, 2, 7, 8. This orange line is not any partition. 10 and 11. So 1, 2, 3, 4, 5, 6. So initially beginning 0 and 6. 0 plus 6 by 2, 3. 3 is this. Sorry. Okay, let me take 5 elements only. Forget about this thing. End is 5. So beginning plus end, 0 plus 5 is 5 and 5 by 2 is 2. So I checked my second element, which is 7. and my threshold was 8. That my guy like all the numbers greater than equal to 8. So logically my answer should be 8, right? Because I want the maximum element. But these numbers are also liked by the guy. So why I am removing? Obviously answer can be 7 also. That way I'm updating this answer is equal to array of mid. But it is also possible that answer lies here. The maximum number lie here. So that's why I'm removing this subarray now, because if this subarray only contained the answer, the maximum element in this subarray is already 7, which I already updated here. So I can safely remove this array and move to this part now. Cool? So explain answer is equal to. Is it cool now, Venugopal? Cool. Great. And as someone Shetty says pointed out, maximum function isn't already really needed. But in some cases, there can be some function also to apply which is needed. So yeah, it depends on problem to problem. You can obviously see that. So that's not an issue. So the time complexity and has multiple sevens. Yeah, nice question. And has multiple sevens. Very nice question, Nikhil. It depends. Let me tell you. Actually, this is a nice question. Yeah. But actually, I don't want to spend more time on binary search. Actually, I don't want to spend more time on binary search. I will tell this answer. But if you want, I will show you the code also. But this is a nice question. Really nice question. So the Nikhil is asking that what if, for example, say in this array only there are more than 8. For example, 8, because we took threshold 8 here, and we want maximum element as well as the maximum index. For example, say there is 8 here also, 8 here also. So I want maximum element. Obviously the maximum element is 8, but in maximum element also I want maximum index, or maybe say minimum index. For example, there are 3 8s. Array is 1 2 7 8 8 8 10. Maybe I want minimum 8. I want maximum 8. Oh, sorry, maximum index with 8. So in that cases, what I can do, if my beginning, if what I can do, if my value of my array mid is equal to 8, cool. Like this code, what this code will do, this code will give me the maximum element, because whenever I am getting 8, for example, if I am getting here, I am removing this and moving to this range also have 8, so it will give you the maximum index which has 8. But for example, if you want minimum index with 8, Nikhil, are you clear with the thing that why it will give the maximum index with the 8? The same code.
Yes.
Yeah, cool. So I hope now your doubt is clear what you meant.
Yeah. So if in the case of minimum index, so if how do we get the minimum index? Like if
okay, for this specific problem, actually your question is very nice. I really like the question, because it in real life whenever you will solve problems on Codeforce, or maybe it will come that this number may do this kind of thing. So in this case particularly, if you want that thing, so what you can do additionally, you need to do one thing additionally. What you can do is what you can do, if your response, because every time your response is 1, you need to obviously remove the left subarray if it is not 8. But what you can do, if your response is 1 and also it is equal to 8, then instead of moving to removing left part, you can remove right part. Are you getting why?
Yes.
You are getting right.
So we are so beginning is 1.
So no, see, whenever element is non-8 and it is less than 8, so you can remove the left subpart and move to right, and right condition will remain same. But whenever the number is specifically 8 the array of mid is specifically 8, then you need to put a specific condition for that thing, that because you know that answer is obviously not going to be greater than 8, the value of answer, but in that also you specifically want the minimum index. So you can basically remove the right subpart, because if you will remove right subpart, if there are 8s there also, then you are removing them and you are getting the lowest index element valued 8, right?
Yes, got it.
Yeah, but yeah, very nice. Cool. Okay. Yeah, I hope this is clear. Nikhil's doubt was nice. If any one of you didn't get the point, no issues. You can maybe revise and do question, then you will get that point. It is a little, how do we know how much value was? Which value was repeating? No, you don't need to know which value was repeating. Like, okay, like Nikhil's question particularly was that in 8 also, he want the minimum element that way. So his question was this. So in that case, you don't need to know which element is this. Cool. So let us move to DP now. Okay, in binary search we are clear. Log n, edge cases we are clear. Like I highly recommend you to use this code. Maybe put max here also for generalizability. And now let us move to DP. Before DP, okay, okay. So now it is already 2:30 and we had till 3. So we will try to cover DP in approximately 45 minutes, like say near 3:15 or 3:20 at max, because the second part of the workshop will be starting at 4. So just just let us take a break of just 2 minutes and let us start DP till at that point. Till then, if you any one of you don't know what are the Fibonacci numbers, na, maybe read this slide or maybe search over the internet or anything. I'm opening this slide and I will be starting now in 2 minutes. will the workshop be only for today? Yeah, there were two parts. Na? First, which I am taking, and second is from 4 to 6, which Dikshit Garg will take. I know nothing about trees. Why? No, in DP you don't need trees, na? You meant in the second half of the meeting, Sarthak? And if you meant in second half, then also we are going to cover from entire basics, so don't need to worry about that. Also, one thing, as in this first part, there were a lot of topics to cover, like space-time complexity, then binary search, and small topics more. So that's why, obviously, I cannot cover DP in full detail, but I will try to make your basics clear. And then we had a meet few months ago, in our college, IIIT Hyderabad, a full-fledged meet for DP, in which we cleared DP basics, which the same way I will cover. That meet also I took. So in the in the initial of that meeting, we covered the basics, which I am going to cover today, right now. And after that, we did some advanced things also, like maybe say 2D DP. And I am pretty sure we won't be able to cover that today because of lack of time and a lot of topics. Because then you will get confused. So, but I will mention you the link that is available on YouTube. So I will mention you the link. You can see that after this session, and that way you will be more clearer with that. Basically. Okay. So this is our programming club channel on YouTube. So this was the DP meet which I took. So the first part would be same as in the today's meet because the host was same. So the same way. So I hope this would be clear. So I would recommend you to watch this video after today's session because the things which were covered in this session, I will obviously not be able to cover that all things today. So I'm mentioning the link here. Is DP and recursion same? We will explore it today only, this thing. I will mention it in resources also. Say DP resources tutorials. Yeah. So this is the okay. I pasted the channel link, but yeah, you can see all yourself. So yeah, instead of wasting time, let us move on. And at the end, we will also discuss something about where to do coding and all if you guys want to stay. But yeah, let us quickly move on to the DP. So see, I hope, okay, just give me a thumbs up if screen is visible and audio is clear now. Visible, cool. And also don't confuse with trees. Why are you thinking of trees right now? Someone asked na, initially. Because we are going to do DP only, so no need of tree. This is a tree, but yeah, right now don't need to worry about tree. That will come in the second half of the meet. So cool. Yeah. So this is the Fibonacci sequence. Fibonacci sequence is a sequence of numbers, say mathematical series, in which a number is the sum of its previous two numbers. Like 3 is sum of 2 plus 1, 5 is sum of 3 plus 2. This is our Fibonacci series. So this is known as our Fibonacci tree. Let us move and do it nicely. So see, yeah, this is our Fibonacci tree. What is Fibonacci tree? If I need Fibonacci number 7, it will be sum of Fibonacci number 6 and Fibonacci number 5. You already know that. If I want Fibonacci number 6 now, it will be sum of 5th Fibonacci number and 4th Fibonacci number. Same way 5th Fibonacci will be sum of 4th and 3rd, and same way so on. So this is the code part, that a function to which you pass an n number, consider it as a magic box. If to this function you pass a number n, so it will return you the nth Fibonacci number. How? This is the recursion code. Recursion thing someone was asking. So in this, what I am doing, int a is equal to Fibonacci of n minus 1, int b is equal to Fibonacci of n minus 2, and int c is equal to a plus b. Fibonacci number n will be sum of previous two Fibonacci number, and just directly returning this c. And this is known as the base condition of our recursion. As you guys already know, I hope, that recursion always has a base condition, which is say the major thing in recursion. So this is known as a base condition, and yeah. So is this thing clear? This recursion function, how this recursion function works? Treat it as a magic box. You pass this magic box a number n, it will return you the Fibonacci nth number y. So let me give you one more thing, one advice. Like at the time when I was learning recursion first, I was very much confused with the recursion. I was not able to analyze what is the recursion. So the best way to think recursion is, yeah, when you are thinking of recursion, treat recursion, this function, this full function, this black function as a magic box. A box. You don't need to worry how to write. Just forget. To that magic box, you pass a function, pass a number n, like in this case, and it will return you nth Fibonacci number magically. Now let us explore step by step. And in recursion and in DP also, remember one rule. If you are at step 1, just think about step 1. Don't think how other steps will work. If you will think, then you will be confused entirely. So if you are at Fibonacci number n, you know only one thing, that sir, Fibonacci number n is sum of n minus 1th and n minus 2th Fibonacci number. So what I did, int a is equal to Fibonacci of n minus 1. Fib is the magic box. I know Fib is the magic box, so I will not worry. This magic box is very smart. If I pass him n minus 1, he will return me the n minus 1th Fibonacci number. So I don't need to worry about how this smart guy works. The same way is for this. So I got my 2 previous Fibonacci number and I just directly return sum of them. So just these 3 things. But there is one thing known as base condition, which we all know in recursion. So this only we need to put. That base condition is this. So is the recursion thing clear? Is my this advice clear? That don't think of previous steps. Might be you guys also face some might be you will also be facing some issues while thinking of recursion. So if it is clear, then I will explain you Fibonacci recursion. This is the code for Fibonacci recursion. I don't think I need to write this code. This is obviously written and I just took a screenshot and pasted it here. If it is clear, then I will move clear, sir. Cool. Now let us move over this Fibonacci tree. Yeah, see. Now just listen carefully. So this is how recursion works. First you call Fibonacci number 7. First you call Fibonacci number 7, it is going to Fibonacci number 6, basically calling the function Fibonacci number 6 and calling the function Fibonacci number 5. Then in Fibonacci number 6, it is calling the function Fibonacci 5 and Fibonacci 4. In Fibonacci 5, it is again calling this is again calling this. This is how recursion works. And when I call Fibonacci 1, as I already told you, this is my base condition. So it will return. Instead of calling, it will return my output. And here also I have not basically drawn, but here also if it will call Fibonacci number 1 and Fibonacci number 0, or basically just Fibonacci number 2 also you can put as a base condition, so that's not an issue. I put it n less than equal to 1, mind it. So n for n 0 it will return 0 and n1 will return 1, so this will work. But so yeah, this way it will give output. But there is one major issue in this recursion. One major issue. Can someone point out? Or maybe okay, don't point out right now, let me explain it. Say when I came to Fibonacci number 1, it returned me the basically its value. The same way it will call Fibonacci 1 and 0. These are also my base cases, so it will return this way. Now this Fibonacci 2 values come, it will return. Now Fibonacci 3 is completed, it will return. Now Fibonacci 2 is again called, it will again call 1 and 0. They will return their values and it will return his value. Then Fibonacci number 4 will return his value to 5. Now the thing is, he will again call Fibonacci number 3. It will again call Fibonacci number 2. Again Fibonacci 1. This will call 1, 0. And this will return. And so on. Then this will return. Then again call Fibonacci 4. Can someone point? We are calculating. Very nice. Too many useless stuff. Very nice. So many of you noticed that I am calculating same Fibonacci number many times. So that is the issue here. And also one more thing I should tell before this, that the complexity of this recursion is it is exponential complexity, because basically 2 to the power of n, not actually exactly 2 to the power of n, maybe something near that. I like, maybe I pasted it in the slide. Actually I forgot to paste. Oh, okay. Let us see what is the exact complexity. I guess it is something of 1 to the 1.5 to the power of n. Let us see Fibonacci recursion complexity in the. But logically we can think it of as an exponential complexity. I will clear out the why logically it is this, and yeah. But exact value, if you want to see, you can see over internet, because I don't want to prove it mathematically. Okay, I don't know where it is. I don't know where it is, but yeah, it is something of exponential sort. We have to do stop n is equal to 1, too many useless steps, space is as we are creating many variables with recursion. Yeah, very nice, Nikhil. Spaces are also, spaces issues are also there, but there are also time issues. So, and also each step is called many times, so that's why it's exponential. If you want to see the proof with the master theorem or anything, you can get it. But logically, can you think why it is exponential? Let me clear out logically it once. Then, just if it is clear logically, then maths obviously you can see logically. Logically, why it is one? See, for example, see, Fibonacci number 3 is calculated 1, 2, 3, 4 times. Cool. Let us see. Fibonacci number 2 is being calculated 1, 2, 3, 4, 5, 6 times. So that's why each number is being calculated many times. So summing to them, it is giving an exponential complexity. For example, say 1, 2 to the power of 1 plus 2 to the power of 2. That way you can prove it also. So that's the thing. So what we can do, and also space complexity is also there because recursion stack is building again and again. So there will be a lot of space. But yeah, Nikhil, as we are taking variables also simple, so it will not give memory limit because we are taking simple variables. So most probably it will not give memory limit depending upon the value of n. So now the thing is, let us do one thing. If Fibonacci number 4 is already calculated here, na, let us store it in an array. And here it is written, if we store it in an array, then at this point when I call Fibonacci number 4, I will not go to these steps. I will basically say cancel this, and I will just directly return my value this way. So this competition is saved. This encircled one. This encircled one. Oh, sorry. This encircled competition is saved. Then when I came to say here as Fibonacci number 3 is also calculated, so this also is getting saved. Let me cross this out also. Then Fibonacci number 2 is also calculated here already. Here. So this competition is also saved. Then Fibonacci number 5 is also calculated here. So this full, see the thing now. This full right sub part of the tree is getting cancelled. I will not calculate it. Why? Because I already calculated 5 here, so I will just directly return the value. Are you getting my point? Anyone? Anyone not getting? To tell me.
So, but how will we implement it?
Yeah, that I am going to show you. No, logic wise, is it clear that if we store the value somehow, then we don't need to. Okay, can you repeat? Okay. So, okay. Akshit, I was saying that if you store the 5 was, 5 was already calculated here using these steps. So I will not calculate 5 here. I will store it somehow, and I will just directly return the value instead of computing this whole subtree again. I will just directly return. Now, how to implement it? See, let us quickly write this function which I pasted there. Int fib int n, if n less than equal to 1, return n, else int a is equal to Fibonacci n minus 1, b is equal to this, return c. So see, this is the simple Fibonacci number or Fibonacci program. Let us take int n, c in n, and int answer equal to Fibonacci of n, and let's print it out. Cool. This is the program which we wrote quickly. Okay, 4. Fourth Fibonacci number it is giving. It is 3. Fifth it is giving. Cool. See, 6th is the sum of 5 plus 3. Also, okay, just let me do one thing. I will give you, because I want to give you the codes after the meet. So this is naive Fibonacci. Naive Fibonacci, and let us, this is Fibonacci with means Fibonacci with memorization. So now this is the naive one, and logic wise clear. Cool. So this is the naive one. But now we are going to store it so that we don't call it again and again. So how to store it? Let us see one thing. Let us take an array globally of say size maybe 1000. Okay, I need to resize it also. Okay, do one second. I need to put the -1 here also. So let us take it manually too, or let us take a vector. Let us take a vector. It is simply an array, but why I'm using it so that it is easy to just put -1 in them. I'm taking a vector of size say 1000. This is known as my say memory array because I'm storing it. I'm memorizing it here. Memory array. So what I am going to do is, if like here I calculated the value of say Fibonacci of n-1, right? So I will store this value in my array. Fibonacci of n, memory of n-1 is equal to a.
What this -1 indicates?
Actually, this is just to basically uh, taking an array of size 1000 and each value is -1. Okay, if you don't want it, I can do it this way: array of size 1000. But now, as you already know, global arrays are already assigned value of 0. So I need to manually put a loop of 1000 and assign the value of -1 to each value. Or maybe you can use memset and all that stuff also, but yeah, sorry. Yeah, is equal to -1. This is just taking an array. Okay. 1 second. Yeah, cool. Okay, by mistake I named memory.
Why should you assign all the values to -1?
Yeah, I will tell you why. In 1 minute, I will tell you. Yeah. So see, now what I am doing is, once I am calculating n-1 as Fibonacci number, I am storing it in my memory array. Same memoizing this term. Remember this term because term should also be clear. This is known as memoization. Memoization, obviously, English is obviously get memoizing, learning, putting in the memory. So this I am doing here. Then I am doing memory of n is equal to c. So I am storing it. Now I stored. Now what I will do, if memory of n is not equal to -1, then I will directly return its value instead of computing it. So the reason why I took value initially, what you say, -1, because to determine if its value is already being calculated or not. You can put 0 also, but that way, yeah, you can put 0 also, I guess. There is no need to put -1, but just take, yeah, actually we should take -1. But, sorry, we should take 0, but I took -1 because just it makes things much more clearer, because obviously there would not be any negative Fibonacci number. If you treat 0 as Fibonacci number, though it starts from 1, so it's just your wish. It starts from 1, so it's just your wish. So we should take 0 actually. I should not confuse you, but yeah, light. Use memset to set -1. Yeah, you can use memset, but I am not using here. I don't want to confuse you if you don't know this function. Okay, so is this thing clear? What I'm doing, once I'm computing it, I'm storing it in my memory, and then I'm checking it here if it is already calculated, just return it. Don't calculate it again and again. Is it clear now?
Hello?
Yeah.
Actually, I got a network issue in the middle. So,
okay, Nikhil.
So can you explain how this memory part comes, like memorization?
Yeah, sure.
Can you?
Till where did you follow?
Yeah, up to the point that there are too many. There is time complexity, exponential time complexity. After that, I.
So can you see this code?
Yes. Yes.
Yeah. So in this code, what I am doing, I already showed you the Fibonacci recursion code, right, Nikhil? This one. This code. This code
Yes,
you
sir.
already saw, right? So here what I am doing, I am taking a memory array, global memory array. Initially, I am assigning values of memory array as -1. So what I am doing, once I calculate any Fibonacci number, like here I am doing int a is equal to n-1, I am storing it in my memory array, right? I am storing it in my memory array, and what I am doing here, whenever you call this magic box, this Fibonacci function for some value, if I have already calculated my memory, like that Fibonacci number, I am just returning it instead of calculating it again and again. Are you getting it, Nikhil? If not, obviously do say. Nikhil, are you hearing? You are muted, Nikhil, I guess, if you are speaking. Okay. Like I am audible, right? Put in the
Yes,
chat.
sir.
Yes, you are audible.
Yes.
Maybe there is again some network issue on his side. Cool. So cool. So this thing is clear, memorizing thing. Okay, let me tell you one more thing. Actually, I should not do this, but yeah, these steps are not needed. These two steps. Why? Because I am already storing it here, na. So these are already being stored. These are already being stored. So I don't need to do them here. Why? Because anyways, n minus one. If I am on n, then n minus one is already being getting calculated. Like basically, when I will call this function for n minus one, then at that time this step will already store its value, n minus one value. So these steps are actually not needed, but yeah, it's your wish. So cool. So this is known as memoization. So uh, let us let us quickly analyze time. Okay, let us quickly analyze time and space complexity. So quickly tell me space complexity. Quickly, just 10 seconds. I know you obviously know what is the space complexity of this code. Oh, this code. What is that space complexity? Not time, space complexity. Please quickly do. Give me in terms of O of n. Very nice. O of n, because I am just storing one array. Very nice. Very nice. 4. Why 4? Wait, 3 words. Why 3 words and why 4? I'm storing full array, na memory array. So why 3 words and why 4, Gautam and Renu? Gautam, are you clear now? Yeah, 1000 is there because I took 1000 size array, but you should say O of n, like. But yeah, it's clear. It's fine. Gautam, are you clear now? Because I am storing a memory array, na. So
Just a minute. Could you repeat it? Why it is n?
So see, like actually not n. Actually, it is 1000 here, but yeah, we say it in terms of n. So that's why I'm saying O of n. But yeah, you can say O of 1000, but it is not 4, right?
Okay, I just actually counted the variables a, b, c,
Yeah.
and n.
So
So
this
yeah.
array is also there, right? Also, general advice: don't just focus on small variables. They don't contribute much to space. Focus if there are arrays, because if there are variables, just say that it is a constant. Like these are some standard means to tell time and space complexity. That because maybe if you are taking n here, someone else is taking m. So by n we mean what is the array size. So that's why many guys said n. So it's general thing, but yeah, obviously it is your wish. Space complexity, as you already said, it is O of n. Why is line 18 and 20 optional? Okay, I will tell you. Just after this space and time complexity. But yeah, right now maybe think that they are not optional because you understood the logic. Okay. And also one more thing, the space complexity of this recursion. Just quickly tell me, Gautam. Gautam, you tell me. This recursion, simple recursion without memoization. Gautam. Any guys, Gautam? Good work.
It was initially 2 power n.
No, not time. Space complexity.
Space complexity.
Of the simple recursion.
Of which one?
Of?
Of which one? Which code?
Oh, which one? Oh, yeah, this one. The simple recursion. Oh, I forgot to open maybe. Yeah, this simple recursion without memorization. This one, Gautam.
Is it n?
Why it is n? Don't hesitate. Yeah, we can discuss obviously. If you are feeling it is n, why?
Is it on?
No. So Tejas, just let Gautam speak once. Yeah, it is 1. But Gautam, can you say why you were saying it is n? Okay, just wait 1 minute. Let me change this. Yeah, till then, Gautam, can you tell me why it is O of n? Why do you think that? Maybe you can just tell me your point. Obviously,
I
we
mean, because in that Fibonacci function, we are going for the, like, if you have to calculate the nth Fibonacci number, we have to go through the previous ones as well.
Yeah, we have to go, but I am talking about space complexity. What are we are storing? Do you mean that we are
Yeah.
storing those variables in recursion? That's why. Are you saying that's why?
Yes.
Actually,
That's what I thought.
yeah, you are one step ahead of us. I guess actually you are right, but in this type of terms, in this when telling this way, we don't calculate the stack space. Actually, Gautam is pretty right. So but I was talking about this only space. Actually, you are right. Why? Because when we are taking the recursion, we store the states in stack. So actually, it is O of n, but many people do include it, or many people do not include it. Like when you will prepare for interviews also, whenever you do some question on lead code, you can see in the editorial they have specially written that if you include the stack space, then the complexity is O of n, else it is O of 1. But yeah, your point was right. But are you clear that here we have not taken the array? So in that terms, the space complexity is O of 1.
Yeah, there is no error in this one.
Very
So
nice, Gautam. I'm glad that you pointed this out. But yeah, cool. So okay, anyone? Okay, cool. When you are calculating, you are also memorizing them. No, see na, I am not calculating them. I am calling the function. If the value is already calculating, I am just returning it. So it will not come to this point. It will just directly return it from here. So that's why I'm not calculating it again. So it will save me the time complexity. Okay, let us move to the time complexity first. So the time complexity of this naive code I already told you is exponential to something of to the power of n. Approximately upper bound you can say 2 to the power of n. Why it was this? Logically because because each number was being called many times. So also mathematically you can prove that. So the time complexity of this code, this memoization is O of n. Let us understand why. Because in this code, every number will be called at max one time. Fibonacci number of any number will be called at max one time. And once it is being calculated, we will store it in our memory array, and we will not calculate it again. So that's why what you say, the time complexity is O of n for this code, this memoization code. Cool. The logic is simple, na. We are just calculating one time any number and storing it and not calculating it again and again. So there are no repetitions. So that's why the time complexity is simply O of n. Cool.
Sir, could you say for which code it was O of n?
For this memoization code, this memoization, Fibonacci with memoization. Is it clear now?
Yes, sir.
Cool. Any doubts till now? Just speak out. Otherwise, I will move to some say DP now, like the other way to write this. Okay, let me tell you one thing before that. So see, this was recursion. This is known as recursion with memoization. Let me write for you because I want you to know the terms also. Recursion with memoization. These terms are really very important. Like many guys don't know the terms, just say yeah, we store it memory, but you should know the term memoization. Why? Because once you are explaining to someone or say maybe searching over internet, so these terms are very helpful. So that's why. Yeah. So so I was saying this is known as recursion, simple recursion. This is known
just to be clear, this memoization one is the one in which we are storing the Fibonacci numbers, right?
Yes.
But we don't
Why?
repeat them
Because
again and again.
yeah. Because what memoization means, storing in the memory. The English meaning of memoization. That's why. And the simple was known as simply recursion. Simple one is recursion. This is known as recursion with memoization. Cool. Gautam?
Yeah, cool.
Cool. So now the thing is, and we also know the time complexity and space complexity. Time complexity of recursion is exponential 2 to the power of n approximately. Space is O of 1. But in memoization, space is O of n and the time is also O of n. So we saved a lot of time. But the thing, one thing is this recursion with memoization is one type of DP. DP, you know, dynamic programming. You might have heard this word. Many people might be scared of this word. In like DP is very important concept in many interviews. Like this is the favorite topic of many companies. So this recursion with memoization is also DP, but there are two types of DP as I already mentioned on this slide. There are two types of DP. Oh, Krishna Kumar, do you, Aishwarya, do you have any question? Because there is some noise. Aishwarya, can you type in the chat? Actually, there is a lot of noise in the background. So that's why I'm muting you. Yeah, just put in the chat. I will, because there was a noise. So yeah, I was saying there are two types of DP: top-down approach and bottom-up approach. These are known as two types of DP. So this recursion with memoization is known as top-down approach. Why top-down? Because as we visualized already, we move from top till down. Top till down. We started from this top point. Top means this. If you want to calculate the 7th Fibonacci number, we started from Fibonacci 7 and moved till Fibonacci 1. So from top we are going to the down. So this, let me write here also. So this recursion with memoization is also DP. Anyone who says this is not a DP is wrong. But this is not a good DP. I will tell you why. This is top-down approach of the DP and known as recursion with memoization. These are just terms, so I hope this is obviously clear. So now coming to the point that there is one more type of DP known as bottom-up approach, which is good DP. Like in layman terms, you can say that recursion with memoization is a bad DP and that is a good DP. Why? I will tell you. So see, okay, this one. Yeah. Let us write one more code and then we will understand properly. Fibonacci. Let me say. I'm naming it DP. Though memoization was also DP. So now I am writing the code quickly. Now see how simple the code is. Okay, let me maybe explain it on this first and then we can move on. See, I have an array. This way. Cool. This is my Fibonacci array. Any array. Okay. So my first Fibonacci number is 1. Second is also 1. Third is 2. Fourth Fibonacci number is 3. Then 5 and then so on. So just answer me one question, that if I am at this position, then I want to calculate this Fibonacci number 1 2 3 fifth Fibonacci number. So this will be the sum of this plus sum of this. 2 plus 3, which is equal to 5. You guys agree with this, right? That this Fibonacci number will be sum of my previous two. So this is obviously clear, I hope. Just quickly tell me. If this is not clear, just quickly tell me. Don't wait for anything, right? And if you're not replying, I am assuming it is clear, right? Okay, cool. Yeah. So I was saying that this number is the sum of previous two numbers. So to calculate the fifth Fibonacci number, I need only previous two numbers. So what I can do is I can take an array simply and traverse it this way. So for example, say that I already gave you these 4 Fibonacci numbers. So to calculate this, I only need previous two. Once this is calculated and say I came over this Fibonacci number, I only need previous two Fibonacci numbers, right? So at each time, I am traversing it this way from left to right. And to calculate any Fibonacci number, I need only previous two Fibonacci number and I am good to go, right? Cool. Yeah, clear. Cool. Thanks. So here I am moving from bottom to up. Like this was my first Fibonacci number and this was my fifth Fibonacci number. So I'm starting from left till right. That is going from bottom to top. So it is known as bottom up DP. Let us quickly code this out so that it is more clearer to you guys. I took an input, say n is equal to, okay, let us quickly fix it and let us take an array only of size n, and my array's first element is 1, which is my first element of DP. Oh, sorry, Fibonacci number. These are the base states. Oh, sorry, I forgot to tell. I will tell you anyways. These are the base states. Then I make a loop over from 2 to n. And each of my Fibonacci number array of I is equal to, array of I is equal to array of I minus 1 plus array of I minus 2. And at the end, I can simply print array of n. So, are you guys clear with this code? Like the logic I already tell you, I started from here and go it here. Why it is working? Because for any state depends on only its previous two states. So are you guys clear with this thing? Yes, sir. Yeah. Any doubt? Please tell me, because with this we will be ending the DP, not ending the meet, but this basic of DP, and then I will most probably do one question, and then we will end the meet. And the question will be based upon this only. Why means yes, I guess. Okay, let me quickly. Athar, is it clear, Athar? Bottom is not a recursion, right? Yeah, it is not a recursion. I will tell you more details of this now. Athar, is it clear? Okay, if you are not replying, then I am assuming it is clear. Otherwise, you can ask the doubts.
Yes, sir, it is clear.
Yeah, cool. Brother. Yeah, so see, this is not recursion, na? This I am just looping, and it's simple. And obviously, you can, I guess, you can quickly tell the complexity. Time complexity is O of n. I am just looping, and space complexity is also O of n because I am storing it. Cool. So time complexity clear, space complexity clear. Why it is known as bottom of DP, that is clear. Right now, there is one doubt in your minds that why this is bad DP and why this is a good DP. That I will tell you. This is one doubt. Just remind me if I forgot by mistake. And there is one thing known as like if you don't understand this thing, just forget. Like here, as I only need the previous two numbers. So instead of storing full array, I can just store three numbers, the previous two and the current one, and update them simultaneously. So that way I can reduce my space complexity to O of 1. And to Gotham, see, here I'm not taking recursion. So here the time complexity is truly O of n because there is no stack space. Right, Gotham?
Yes, sir. Here there's a for loop, so we are traversing through it n times. So
Yeah.
over.
So also Gotham, did you got the point how we can reduce the space complexity in this question from O of n to O of 1? O of 1, I mean constant time space. Because logically, I won't code it because we don't have much time, and obviously you can do that on yourself. That to get any number, you only need the previous two. So instead of storing all the, like for example, let us take, say there are 1,000 numbers. If you're storing 1,000 number and now you're calculating 1,001 number, you only need the previous two numbers, 1,000 and 999. So you only need the previous numbers. So you should store only two numbers. Why to store these full array? Because we don't know these array now, na? So that is one optimization technique. But yeah, if you don't get it, just forget or maybe try it yourself. I'm not focusing on this much. So this thing is clear. Now there is one terminology I will tell you. Sir, finally time complexity over. Right? Yeah, time is. Yeah, in this code it is this. Yes, sir, got it. Cool. In this code it is this. And also Harsh, Suresh, and all to everyone, do try to code up the Fibonacci with space complexity of 1 and time complexity of n. By the way, I already told you. And by space complexity of 1, I mean constant. It would obviously take 2 to 3 variables. So yeah. So cool. What I was going to tell, I will tell you now the terminologies of DP, which are these things. Then I will tell you why this is bad and why this is good, and then we will quickly do one question, and we will be over by at max 3:30. So you will have a half-hour break for next session, which I guess is more than sufficient. Yeah. Okay. I have got message of someone. 1 second. That someone is not able to join the meeting. Okay. Nikhil, are you there in the meet?
Hello.
Yeah, Nikhil. Sorry, I read the message late.
Sir, I joined just now, so I missed. I don't know what. I missed a part of it. So when you were explaining memorization, I again got the issue of networks.
Now your network is stable, right?
Yeah, I just joined right now. Yes.
No, you will not get the recorded lecture, SRK. So yeah, Nikhil, I was just telling that instead of calculating Fibonacci number again and again, you can store them, and that is known as memorization trick. So did you got the top down and bottom up approach, which I told now?
No, sir. Actually, I missed because when you were explaining, I was having network issues. I couldn't join.
Oh. Okay. Actually, it would not be possible for me to repeat because it will take at least 10 minutes. So maybe just try to follow now, and like afterwards you can message me. I will tell you to you personally or something of that sort. Cool.
Yeah, that will be fine.
Yeah, because if I will extend now, so the second meet will also get affected, which I don't want. They won't provide us. Yeah. So what I was saying, yeah, please mute now. There was some noise. Yeah, so I was saying like why top down is bad and why bottom up is good. So in top down DP, memorization DP, Nikhil pointed out, oh sorry, not Nikhil, Gautam pointed out one issue, one thing that in stack also we are taking a space. So see, whenever we do recursion now, how recursion works, so recursion basically works with the help of stack. When you call a recursion for say n, it will store the state of recursion in a stack. Then in that recursion, you were calling Fibonacci of n minus 1 and n minus 2. It will again call those function and store it in the stack. So recursion works by some stack way. Like I'm telling the working of recursion. So it builds up a stack. So due to that, now there is something known as stack limit error. Basically, stack limit got exceeded, memory limit of stack. So that is the issue in your bottom up DP. That because you are doing recursion, obviously you are not calculating the sum that thing again and again, but still you are calling the function again. So it is building up in the stack. So stack size might get exploded and you might get an error. So you can check that error also by running that code for maybe 1e6, or maybe let me show you quickly. Next lecture start from 4. Next lecture will be from 4 till 6. So yeah, that is the issue in your stack. And also as Gautam only pointed out that in stack it was taking space also. So that is also one issue, but the major issue is stack limit exceeded. But for the general problems, like if you do problems on any platform, like I also did many problems with both the approaches. So I never faced the issue of this stack limit error because many programming sites put the limits, constraint limit that way so that you don't get the stack limit error. But the good way to do DP is this only. Like this is my general advice, but yeah, it entirely depends upon you. Because if you are able to do the DP with the bottom up approach, then you will get highly like proficient in the DP. So that's why that was the thing why it is so. Now I will quickly tell you the terminology of DP terms. There are some terminologies, like there are 3 terminologies in the DP problem, any DP problem: states, transition, and base state. Just like listen this carefully because Nikhil, you also listen this carefully because like if you will see the video which I gave you, I have done maybe 3 to 4 questions in that meet. Uh, and I've always used these terms. Cool. So see, this thing is known as the base state of DP. I'm talking in terms of bottom of DP because I've all explained every question in that way, so that's why it will help you more. So in this bottom of DP, this is known as base state. What is base state? Which you are not calculating, which you are just putting the value directly. So this is known as the base state. And obviously base state is more clearer because you already did that in recursion also, that this was the base condition. So this is known as base state in DP. This base state. Cool. And this array is known as the state, DP state. DP state. What is DP state? An array or maybe 2D array, some vector in which you are storing, basically in which you are storing your number. So to pronounce in DP terms, this array is known as an DP array, which for which the nth value of DP array represents nth Fibonacci number. So what I can say here is my nth DP state represents nth Fibonacci number. So this is my known as my DP state. This array is known as DP state. This is known as base state, and this step is known as transition step in DP. These 3 are the major things of DP. Major things. And why it is known as transition step? Transition step means like how you are calculating from previous state, like how you are making the link of the current state with the previous state. That is known as the transition step of the DP. So these 3 are the major things in the DP: base state, transition step, and your states. So yeah, to get the nth number, why we don't print array of n minus 1 index start from 0. Yeah, it's your wish, however you take it. So don't worry about this. Yeah. Yeah. So I was saying that whenever you get a DP problem, I will just do one problem due to lack of time. Whenever you DP problem, first you need to recognize the state, then recognize the transition. Because base state is very easy every time. Because what you need to do base state is just like think the minimum possible value and just put it. So this is the thing. And I've put an advice here: don't think of previous state while calculation of current state to avoid confusion. It is a kind of induction. You might have done induction in your +2 class or maybe 10th, I don't know. How to identify a DP problem? First is obviously practice, and the second way is to focus over constraints. Table was doing this are just an optimization variables which you can. Okay, let me quickly do one code and then we can over the meet. So this is the best source of DP question. Like best, like I don't have words how good it is. I've also mentioned its link here. This way, and these are the solutions to these questions. So let us quickly do one code, and then we will. This is very simple code it is. So let us study, like just quickly read out this problem, and then I will explain you. So the problem will be taught in the second. We will answer this question afterwards. So what this problem states, it states there are n stones number from 1 till n. The height of each stone is h of I. Basically an array is given. There is a frog who is initial on stone 1. He will repeat the following action number of times to reach the stone n. Basically the aim of frog is to reach the stone n. If the frog is currently on stone I, jump to stone I plus 1 or stone I plus 2. If he jumps to I plus 1 or I plus 2, he can only do 2 possible moves, and this is the cost of that move. So we need to find minimum possible cost. So let me explain you the question with this. So the question says that we have an array. Basically there are n steps in my array or something, and there are n steps numbered from say 1 till n. This is 1, 2, until n, and these are n stones basically, and each stone has some height value h of I, which is given to you, and an array is given to you. So now the problem says that a frog can jump. Basically your frog is initially at this position and he wants to come at this position. But how frog can jump? Frog can jump from any position to its next position or next to next position. Like for example, if it is at 2, then he can go to 3 or to the 4. But there is one thing here. If he goes jump from 2 to 3, there is a cost which is h of 3 minus h of 2. And if he goes from 2 to 4, then there is a cost which is h of 4 minus h of 2. So we need to get a set of steps to go till nth destination point in minimum cost. Like what we can do, go from 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and 6 to till n. But we cannot just randomly do it. We need to minimize the cost. Just quickly tell me, question is clear, na? Quickly tell me.
Question is clear.
Yeah, question is clear. Cool. So now what we can do, see. Okay, someone is unmuted. Please. Yeah, cool. So in this problem, I will take a DP state, say this array, DP of n, where DP of n means minimum cost to. Okay, just one second. DP of n means minimum cost to minimum cost for frog to move from 1 to n. Like n here means, okay, let us don't confuse you. DPI. This is my state. This is my DP state. Now for every problem in my second that recorded also, I will teach in terms of these 3 states. So see what I'm saying. I'm saying that DP state. I'm telling you this is my DP state. That my DP state is this thing. Yeah, my DP state is DP of I represents minimum cost needed for frog to move from 1 to I by any jumps. Like for example, if I is this, he can jump from 1 to 2 and 2 to 3, or he can directly jump from 1 to 3. Na? So the path which takes the minimum cost, this DPI represents its cost, right? Everyone clear with the DP state? Quickly reply, then I will go over the transition. Yes, sir.
Can you repeat the DP state, please?
Yeah, so I am telling you that DP state is an array where DP is just a name of my array. You can take it anything, just it is just a variable name. But I am just, yeah. So DP of I means minimum cost needed for the frog to move from 1 to I. So say for example, my frog is going from 1 to 3. There are two paths. He might go from 1 to 2 and 2 to 3, or he might directly jump from 1 to 3. Or for example, if you want to come to 4, he can come to 1 to 2, 2 to 4, 1 to 2, 2 to 3, 3 to 4. So there are a lot of paths based upon his jumping, but this value stores the minimum cost needed. Minimum cost which is possible to go from 1 to I. Right? Cool now.
Okay, clear.
Yeah. So now let us move over DP. Yeah. Let us move over the transition step. Now listen carefully. If this is done, then we are good to go with the code also. So see. Now I am saying, see, assume that I am at state 4, and I already tell you that if you are at some state, don't think of previous state. For example, if I am state 4, then assume that everything is being calculated till this. I already know the value of DP of 1, DP of 2, and DP of 3. This is my assumption. I told you so that you don't get confused. So you have this. Maybe someone gave you some magic box gave you. So now you are at this state, DP of 4. So now you know that at 4, frog can come from 2 or either 2 or 3. Like this can be the one possible jump, or this can be the one possible jump. There is no other way. Is this clear? Is it this point that if you want to come come to the 4, you can come from either 3 or 2 in the previous step. Is it clear?
Yes, sir.
Yeah.
Graph. So this is the thing. So what will be my transition step? DP of 4. Please unmute some. Nikhil, you have any doubt?
So, sir, we are moving in one way only, na? 1 to n only, na? Not
Yeah, 1
backward.
to n. Yeah, 1 to n.
Yeah. Okay. Thank you.
Yeah. So DP of 4 is equal to DP of 3. Like, not DP of 4. Sorry. Yeah. Like let us calculate the value of this path. I'm sorry. Yeah. This path. When my last jump was from 3 to 4. So when my last jump is from 3 to 4, what will be my cost? DP of 3, that is cost needed to come from 1 till 3, plus the cost which is needed to jump from 3 to 4. And what is that cost? As you already mentioned here, yeah, that any cost to jump from any is h of I minus h of j. So it will be absolute value, because he has already tell absolute value, h of height of 3 minus height of 4. Is it clear? Like if I take this last jump, why this is so? Because I already tell you, don't think of previous states. As I already have value of DP3, so the cost of my last step will be this much. So DP3 I already have, so my last step is this only, right? So is this thing clear? That if I come from 3 to 4, then my cost will be this thing. Assuming that I already know the value of DP of 3, right?
Yes.
Yeah. So this is the first way. The second way is to come from 2. The value for that will be DP of 2 plus absolute value of h of 2 minus h of 4. This would be clear, right? I assume this is clear. This second step also. This is when I do this jump. So assuming that I already know the value of DP of 2, my last step's cost is this much. This. So this is also clear, right? This is exactly same. So I guess this is also clear, right?
Yes.
Yes, sir.
Yes.
Yeah. So now comes the final game. Now is the final game. So now, as we already know that we need the minimum cost. So what would be DP4? DP4 would be minimum of these two, because these two are the only possible ways to come here. So this is h of 3 minus h of 4, or DP of say 2 plus absolute value of h of 2 minus h of 4. So is this thing correct? This thing. So my DP4 is minimum of both. Why minimum? Because I want the minimum cost, and I know that to come to 4, there are only two possible options. First option is this thing, and second option is this thing. So I will take the path which is giving me the minimum cost and updating my DP4 state, right? This is known as DP transition. Clear to everyone? Just tell me.
Yes, sir.
Cool. So now my state is done. My transition is done. What is left? Base state, which is very simple. What will be my base state? That at first step.
Sir,
Uh-huh.
yeah, can we write the dp of 3 is equal to absolute value of 3 minus absolute value of 1, h of 1?
But you need to add the DP of 1 also, na? Though it is 0, but you need to add that also, na?
That means what is the value of dp of 3?
No, yeah, see, he is confusing. I already tell you, see, I wrote here a point also that if you are calculating DP4, if you are at any state, don't think of previous state. So that's why I told this step. So don't think don't think how will you calculate this. Just do this thing, right?
Okay.
Yeah. So don't think of DP of 3, because if you will think, you will not be able to do DP. You will get confused. So these two steps are clear. Now coming to the base state. This 1 is my base state because I am not jumping from anything, and this is my first thing. But 1 is obviously 0 because my frog is initially present. So cost to come from 1 to 1 is obviously 0. And you can treat this also as a base state, that to come to 2 there is only one path. You can only come from 1. So that is also base state. So let us quickly code it up in 5 minutes. Yeah, just a.cpp, task name is A. So see, I took an input n. Okay, array of size n. Then I took an input C in A. This is my height array. Let us name it height. I will change it at above. Height A. So see, now my input is taken. Now coming to first let us take my DP state. My DP state is an array, as I already tell you, array. I name it DP of size, or you can say cost also. But yeah, let us name it DP. DP array of size n. This is my DP state. Coming to the base state. Base state. Okay, I will write base state at the end. But you will get confused that way. Cool. Let us write base state.
भैया एक मिनट भैया this recording be made available to us?
No.
Okay भैया.
Yeah. So base state is, I already tell you, DP of 0 is already 0. This is in terms of 0 based indexing, and DP of 1 is I can only jump from 0. So it will be DP of 0, which is already 0, but I am still writing so that you don't confuse. And height of, why it is not auto completing? Okay, good. Height of 1 minus height of 0. So this is DP of 1. So this is my base state, and now my transition steps. I will start from 2, and my, okay, let us write the first path. Cost of first path cost is equal to DP of I minus 1 plus absolute value. Why this is not auto completing? There might be some array. I don't know why. Okay, cool, no issues. Yeah, I minus 1. This is my first path cost, and this is my second path cost. Second path cost is equal to this thing. Now my DP, DP of I is equal to minimum of first path. There might be some compile time that issue. That is okay. Let me check one. There might be some compiler. That's why it is not auto completing. Yeah, LLI was there. I was saying that there was some compiler. Cool. Yeah, so this is known as my transition step. Minimum of those two parts. At the end, I am just need to print DP of n, which is my final answer. And yeah, let us check with the example. Someone's mic is unmuted, please. See. Oh, index 4 is out of bound. Oh, I need to take +1 here. What it is? What I did. 1 second. Oh, it is giving at here some issue. Why I'm getting the issue? 1 second. Line number. Oh yeah. Sorry. It was, see, it is saying issue in line number 29 and by mistake I saw line number 17. So let me do undo. Yeah, the issue is it was zero based indexing, so I need n-1. Sorry for the issue. Yeah, now let us run the code. See, the answer is 30 and it is matching. Cool. So line number 9 instead. Yeah, thanks. So this was the code. The base state, transition step, and all that stuff is clear. This was the DP code. Time complexity is O of n. Space complexity is O of n. You can reduce the space complexity to constant by don't storing full array. And let me see if I missed something. Yeah, I just need to tell one point here. Till now, if everything is clear, we will close in at max 5 minutes now. Anyone? Is it clear? Please tell me.
It's clear.
Yes, sir, clear. Cool. So now just one last thing. Though it doesn't make much sense in this problem. So in DP, there are two properties. First property, one property is optimal subproblems. Let us see this first. Optimal subproblems. That is, in any DP problem, a problem can be formulated in terms of DP if we need to calculate same problem again and again. Like in Fibonacci problem, you already saw, na? We were calculating Fibonacci number again and again. So that is known as overlapping subproblems property. That is, same problem is being called again and again. And one is optimal substructure property, which is that there is some transition step. We can write some DP of n in terms of previous DP states optimally. Why optimally? This is not clear in this example, but yeah, you can you will be seeing these concepts after doing some questions. So, but yeah, they are present in these concepts also, but it doesn't make much sense here because here the answer was one exact value and not any optimal step. That's why. Okay. Apart from that, like I told you, the this practice problem set, the AdCoder DP contest. So like this is the best source for practicing the DP questions, right? So it contains 26 questions, and like maybe say first this I already did, and first few are like standard ones, like this knapsack LCS are the standard ones. So but I would, could you explain the last part? Okay, I will explain 1 second. So you can see this meet, do serious meet, because in this I've done a lot of questions. So yeah, last part you meant last part in the code I just did printing. Now what you last part what you meant? Okay, okay, I will tell you. These are some DP resources. These are some tutorials. This one is very nice. Do see this one because the host is same, so it will relate you much. And I explained in this meet according to the one I told you today. So this will make things more clearer. These both I have not much this I have not practiced, but I just mentioned it here. This USACO one and this Geeks or Geek also you can see, but I will advise you to see this ones. And in the problems, I have this already told you, this AdCoder DP contest, and these are much more problems like Codeforces and all, Codeforce DP tags and some blogs are there. Just last advice is remaining AdCoder. Okay, I will tell you. Will share the PPT. Yeah, I will. Obviously, I will share this all stuff. Maybe yeah, we will share this stuff over email or maybe something. Yeah, I will just maybe in the till the next meet only I will give you the next session. Yeah, I will share the PPT and all codes. I will put it in the up in the drive and I will give you the drive link. Okay, everything clear now, right? If everything is clear, then I will come to the last part, which is just an say advice. Okay, cool. Yeah, so the last part is like there are some sources to practice the problems. Like the famous one are Codeforces and AdCoder. So and the CodeChef is also there. So if you want to, this is just a general advice for practicing competitive programming. In next session also we will tell you, but yeah, I'm telling in the perspective of DP. So this is Codeforce's website. There are some regular contests here occurring, and the problem set, you can give the contest. There are problem sets. You can apply the filters, difficulty filters, rating filters, and topic filters. Like here you can apply DP filter also, see, and do the DP questions. I already gave you one link. After applying filters, this one you can try this. These are of 1600 difficulty level. The starting difficulty level is 800. So you can practice here, and you can basically see all the like problems and all that stuff, and then there are graphs also of your rating. So this is a very good website. So there are regular contests here, you can practice them. Then on CodeChef there are contests like long challenge and all that stuff, you can give them also. In my personal, this is just a personal advice, that I find long challenge quite useful. Though the issue is that in long challenges there are a lot of cheating cases, but if you want to just learn things, then long challenges are good. Like you learn various concepts. This is not just related to DP. Like you learn various concepts. So there are long challenges every month. I hope you guys know that. It is of 10 days duration approximately. So those are there. But yeah, there is a lot of cheating in these contests. So in this one, not in Codeforces, on this long challenge, because it is of 10 days, na. So that's why. But if you want to gain knowledge, then it is good for you. And then on AdCoder, this is a very famous website. There are some contests of, say, AdCoder beginner. So these are pretty easy contests. There are problems from A to F. First 2 to 3 problems are pretty easy. A is so very, very easy, like just a 2 to 3 minute problem. So you can try to give this contest and all that stuff. And coming to the interviews, like many of you might be, and Geeks or Geeks, obviously you know, I hope. And coming to interviews, you can practice from LeetCode. Like there are basically there are specific sections like top 100 like problems, interview special problems. You can practice from LeetCode for interviews. Why LeetCode? Because many times many companies ask same question as of LeetCode in their interviews. So that's why LeetCode is preferable. And people do put their questions on the LeetCode after giving their interviews. So that's why. And there is one more site, one more famous site, InterviewBit. Though I personally like LeetCode more, but yeah, it depends on person to person. It's your wish. InterviewBit is also there. So for interview specific, you can do LeetCode and InterviewBit. And apart from them, I already told you these 3 things. So any doubt you can ask, or else you can leave. Next session will be at 4. Taken by Dikshit. He's also there, I guess. Dikshit, you are there, right? Yeah, Dikshit.
Yes, I am.
Yeah, so in next session, Dikshit will be teaching mostly graph concepts, trees, graphs, and binary search linked to that session. Yeah, in this meet only, we will schedule a meet right now, or maybe Dikshit has already scheduled. So just join that meet and you're good to go in this Teams channel only. So yeah. And yeah, I was saying like in that meet, Dikshit will be covering graphs, BST and all that stuff and giving, yeah. So those are very important concept. Graphs is like very important concept of your coding. So do attend that also. Like we will in that also it will be a purely beginner friendly. Firstly, like he will start from pure basics, so don't need to worry. Like someone was saying initially that he don't know trees, so he will give every definition, what is tree and all that stuff. So I guess it is cool now. If you have any doubts, you can stay or else you can leave. And I will give yeah Nikhil.
So second session will be till with what time?
Dikshit, maybe 6 I guess, or maybe
tentatively 6. Yeah.
Can you start early, because I have some important work, so that's why.
It's already 3:40. How can you start early?
No, actually the thing is, Nikhil, like, because we already gave the time to other students now, so it would be kind of difficult. That's why we don't have problem. We are obviously available. Dikshit is already here, so but yeah, other students might have some want to break. So
where do we join for the next session?
Yeah, I told her in this teams only there will be a meet created scheduled. Like the way you join this meet, here only just. So you don't need to go anywhere.
Only, right?
Yeah, in this team only.
Okay.
Yeah. Cool then.
Sir, hello.
Yeah.
Actually, when you had been explaining Nikhil's question about like repeated numbers while the smart guy problem,
Yeah.
not necessarily that you will be finding a maximum number as 8. There may be a maximum number which is 7, for which you should find the minimum index. So we should write the code accordingly, right, Mr.
No. Like in that problem, my question was that that smart guy likes all numbers less than equal to 8. So that's why Nikhil told that 8. In 8 he wants that number.
Yes,
So
sir.
but
If the array doesn't contain the number 8, we should
for that specific problem, you need to like put some more if else conditions. So that would not be a good problem. Because I took that problem only to explain you the binary search. So that problem is not apt for that doubt. But for other things like maybe you can play with indexing and all that stuff that way.
So one
like the
more
way
doubt.
we did for 8, na, that's why.
Yes, sir. So one more doubt. When we are doing just normal recursion without DP and without memorization, actually we are calling so many functions, right? So we are doing the same thing again and again. So for that time, space complexity would be 2 power n, no, sir. Like same function you may be calling many times. Each function calls 2 more functions.
No, but good doubt. But the thing is, let me tell you, good doubt. The doubt is really good. But the thing is, once your DP state is calculated, na, you are returning from that function. So once you return from a function, na, so the space it consumed on your stack gets freed. So that's why the space limit didn't come. So the space limit isn't 2 to the power of n in that case.
No, sir. Suppose if we are not doing DP, it will be 2 power n, no, sir.
No. If you're not doing DP also, then but you are returning from that, na, so that is the local space, not a constant. Like let me tell you, once you are calculating say Fibonacci of 2, you called Fibonacci of 1, and the Fibonacci of 1 function will give a return value. So the space the Fibonacci 1 function consumed, it will get freed once it is returned. So the space is not that. That's why.
Okay.
Yeah,
sir.
in this team only. Yeah, second session will be in this team only.
Yes, sir.
Yeah. Cool then.
Yes, sir. Thank you, sir.
Yeah, then. Cool. Bye, guys.
Sir.
Hello.
Yeah.
Hello, sir. Could you please explain the last part in the code, like how you got the final answer for that question?
Yeah, the DP of n-1.
Yeah. Yes, sir.
So basically, 1 second.